Welcome everyone to Lunch with Larry. Today we're going to talk about product design and risk management. Part of the discussion is going to be more related to the negative view of the design. How do we assure something bad doesn't happen rather than what do we want the design to do? So when we talk about systems modeling, it's really the positive view of the design. What do we want it to do? In this case, we're going to be analyzing the different requirements in the design to assure something bad doesn't happen. So that's really what today is about. Just to give you an idea of how to get a hold of me, this is my contact sheet, has my email, phone number, our website, my LinkedIn account, and an area here to schedule a meeting with me. Feel free to jump on my calendar and schedule a meeting, or you can forward design ideation registration link to a colleague, and that'll give them access to all the assets for these different webinars that we're doing. They can get on and see the content just like you are today. So feel free to take a look and use this information as you need to. So today we're going to talk about risk management, and as I usually say in this part of the discussion, this is really about comparing notes. There are a lot of different ways to do this, and different companies, let alone different divisions inside of companies, all have a different view of how to implement risk management. So don't be intimidated by the discussion, because we're just going to talk about pros and cons and try to get an understanding of important factors as we develop this. So that's what we're going to talk about today. The first thing, of course, in any control situation where we're developing a set of assets is requirements management. That's the core data set that all of the different sort of perspectives on the data need to enhance so we get a complete set of requirements. Verification and validation is what we talked about last week. We're going to need to understand what is our evidence that this design complies with our definition of good. Risk management is today, and we're going to talk about that negative view of the design that I just discussed. Standards management, how do we integrate external standards management? It would be next week. And then systems modeling, our model-based systems engineering, how do we construct a formal graphical understanding of the device function and how the different functions relate to one another and how that relates then to the requirements. Again, that's the positive view of the design. What do we need the design to do rather than what do we need it not to do? Okay, when we wrap this whole thing up, what we're going to find is there's all kinds of aspects of work that we can use AI to enhance. So what we want to do is we want to take the work that's already been done, use that as part of the prompt and the training of the agent to help us build out the rest of the design. So we'll talk a little bit about AI as we go through, but this is just a note that we recognize the fact that these productivity improvements are really important to the overall deployment and implementation of requirements management. Okay, so requirements management, we have this decomposition of requirements from what the user needs, and then what we're going to do is we're going to progressively refine what the user needs into a set of design requirements. System requirements, design requirements, physical requirements, and then process controls when we get down to the production process. We also have a set of relationships, as we discussed in the requirements management, where we have refinement relationships, where we can have a parent-child relationship between any one level. So the system requirement can have subsystem requirements that are also system requirements. In other words, we have this hierarchical relationship that we can establish as a parent-child between different work items of the same type. Then, of course, we have the systems modeling that sits over the top of it. And in systems modeling, we're going to define capabilities, functional chains. So how does the device function across multiple components of the system, which are then related to system requirements as outputs of the functional chain. Functions as they're deployed in one component of the system and how they're related to design requirements. So this model defines what it is that we're going to build. How do we want this thing to actually function, and what are the different characterizations that define the outflows of those functions and functional chains? So that's kind of the construction that defines what is good product. So when we talk about risk management, those design requirements really represent the entire mitigation strategy across everything that we can control in the design. So once we've defined and tested the user needs, system requirements, design requirements, physical requirements, and process controls, we've now assured that the design complies with everything that we've defined that says it's good. Now, when we evaluate risk, we're going to have to understand what is the impact to users? And that raises this question about how we systematically evaluate the product risk in order to assure the user safety. And the top level of this for almost every framework that's out there, and irregardless of industry, is that we have this sort of three-piece evaluation. where we evaluate the injury or the harm to users, and we delineate what the severity of that harm is, and then we evaluate any mechanism that could create a situation where we're exposing the user to that hazard, which results in injury. And so that mechanism has an exposure occurrence, the harm or the injury has a severity, and we pair those together with this risk item that can be referred to as an ASIL or a risk record. A lot of different terms for different industries, but essentially what we're going to do is evaluate that paired exposure occurrence with the end effect, which is the injury and harm, to give us a sense of how bad of a problem is this. Now, there's a couple different standards that we use to do this. I'm just going to give you two examples for two different industries. Functional safety, the 26262 standard, ISO standard, defines this ASIL, which is the automotive safety integrity level. That's one of the ways that people evaluate user risk. Or ISO 14971 for medical device discusses this as a risk to users based on hazardous situations and harms. So the terminology is different, but essentially what we're doing is the same. We're just evaluating what is the end risk and what is the severity of the injury that could result as part of that. And as part of that, then when we do the calculation, we're going to identify then how bad is this particular problem. Now, the problem that we're going to run into here is we've now evaluated a harm and a mechanism of exposure, but how does that relate to the design? And what we want to be able to do is understand, okay, we have this high-risk ASIL or risk record. How is that related to the design so that we can progress down into the design, the requirements, the importance of any particular requirement. So if we have a high risk that's identified as related to a particular system requirement, then we want to stamp that system requirement with a high-risk moniker so that as we do the testing, we understand the rigor with which we're going to have to evaluate that system requirement or design requirement or all the way down the chain into the manufacturing process. So that's really what the next discussion is about, is how do we make that link between the requirements and what we've identified as a user risk? Okay, so the first thing we're going to do, again, is identify the risk record in terms of one harm and one hazardous situation or one exposure occurrence so that we can evaluate them together. And you might have a lot of different examples of this. One in a previous life that I had was we have injury that's infection, or we have injury that is a wellhead blowout. What's the mechanism that could occur to expose the user to that particular harm? And so if we think about this as acronyms, the S, or the severity of this issue, is related to the harm, and the P1 factor is really this occurrence. How often does this mechanism of exposure happen? Once we understand those two things, we pair them together, and you can imagine that when you pair a particular severity with a mechanism, you get different rates of conversion. And so we have to understand both what is the mechanism and the injury that could occur so that we understand better how often that exposure is actually going to lead to the severity. So we're going to pair those two together, and we're going to calculate what is the overall occurrence of the harm. So the P1 is how often this mechanism occurs. P2 then, that's associated with the ASIL level. That P2 factor is how often it converts. So how often does, when something happen, convert to the harm that is identified? So maybe a good example of this is we have a case design, and the case, if you damage the wires, you can short the mains to the case. And so what happens is the case becomes energized. So we have a mechanism where we're going to expose a hazard, which is electromagnetic energy. We're going to expose that hazard to a user. And if they touch the case, you might have two different harms that could occur. You might have electrocution or you might have shock. You can imagine that when the mechanism occurs, which is shorting the wires and exposing the mains to the case, how often when you touch that case, it leads to shock is going to be a different conversion factor than leading to a heart attack. So you need to know both what is the mechanism. So how often does that actual short happen. But you also need to know the harm, because 100% of the time when you touch the case, you're going to get shocked. But maybe 0.1% of the time, you'd actually fall over dead because you've been electrocuted. So we need to have a pairing of this severity of the harm with the P1 so that we can understand the P2 factor, which is this conversion occurrence. How often does that P1 actually lead to the harm? So what we do then is we cross how often the exposure happens to how often the conversion will lead to the harm, and then that gives us this P factor. So how often does the harm actually occur? RPL is this priority level. So what we're going to do then is we're going to say we're going to cross how often the harm occurs with the severity of the harm to get how important is this particular combination to the user's safety. Okay, so this is really a calculation of how often and under what conditions this harm could occur so that we have the possibility of mitigating the problem. So once we get that top level assessment done, what we're going to do then is stamp this ASIL or this risk record with how high is the RPL. And if the RPL is high, we're going to stamp it with this importance factor. We're going to give it a thumbs up that says this is something we need to be really concerned about in the design. So when we move down into the evaluation of the design, what we're going to do is we're going to look at the system requirements as they're related to these systems functional chains. So what are we trying to deliver across the system? The system requirement is an outflow of that overall functional chain. And it's a characterization of what we want to get out of the functional chain. And what we're going to do is we're going to evaluate each one of those system requirements for the potential risks. And those system risks then are going to have root causes and mitigations that are design requirements. So once we do this in a systems failure mode analysis where we evaluate the risk, we evaluate the root causes and the mitigations that are the design requirements, that line item that is going to deliver the system requirement can then be connected to the risk record in a causal relationship. So this system risk causes the problem that leads to this hazardous situation. Now, the nice thing about that is since we've stamped the high RPL, this risk record as a high RPL, it also through the traceability will stamp the system risk and the design requirement that is the mitigation to control it. So this is really what the FMEA is all about, is to evaluate this failure mode and effect, get a root cause, and develop a mitigation strategy that's the next level down in the requirement set. So those design requirements then get analyzed themselves, and they're outflows of individual functions that are delivered in one component of the system. So those design requirements then are evaluated with design risks, again, failure mode and effect. We have root causes, and then the mitigation are physical requirements. So if I have something, for example, that says I'm going to seal a vessel, that vessel sealing or the lack of leaking of that vessel is related maybe to a weld. The physical requirement would be the specifications on the weld that are needed to assure that that vessel remains sealed, just as an example. And what we'd want is those physical requirements to get into the design so that we can test and assure that they are appropriately designed to deliver that functional requirement that was developed in the design requirement. And again, when we connect it to the risk record, that high RPL will progress down to the physical requirement and get stamped as important as well. Then we take the physical requirement, we run that through a process risk failure mode analysis. Again, we get root causes, process controls, and if it's connected to the risk record, again, we get this stamping. So this is really the data model that allows us to take an analysis at a high level and then connect in the design to the things that are going to be the mitigations through a causal relationships as part of the analysis. So we're going to talk a little bit more about this, but I'm trying to give you a framework. What we're going to do is progress down the design through these different levels of the design requirements so that we can establish this relationship between how the design is built and the potential issues that it can create. All right, so if we have our design decomposition, as we discussed before, the question then is how do we do this systematically? We have a user need to system to design requirement, and what does that look like when we're actually going to build out these different reporting structures? So The systems failure mode analysis then takes that system requirement, and this is just a different view of it to make it a little more clear. We have functional chains in the systems modeling. The outflows of those functional chains are characterized by the system requirement. We're then going to analyze those with risk, develop a root cause, and then have a set of design requirements that are needed to assure that system requirement is met. So we analyze it with failure modes and occurrence rates, and we determine the design requirements necessary to assure that function is realized. So this is really what the system failure mode analysis is going to look like. Now I'm going to jump out now into a demonstration of the system failure mode analysis and kind of show you how this breakdown happens. And also at the same time, I'm going to look at the top level analysis, which is the occurrence mechanism and how it's related to the harms and how we do that calculation in the tool as well. So, okay, let me jump out. Okay, so now that we move into the tool, so I can give you a little demonstration of how this works, first thing I wanted to do is sort of explain how the reporting structures are set up. So we essentially have two work items that we're keeping track of. One of them is a risk work item, and the other is the mitigation work item. Now we can set those to any work item we choose, but this structure is important because the parent-child relationships are what's picked up in the reporting. So parents of the risk work item are going to be functions, requirements. This is sort of generically how it works, or other upstream work items. We can show those in the report. And also the mitigation are children of the risk work item. We specify what that is, and in this case, it's going to be what we're going to call a design risk. And we can also have downstream work items to the risk work item, and one of those is going to be defined in this particular example as a root cause. So anything can be connected to the mitigation work item. And so what we're going to have there are going to be system requirements, design requirements, and physical requirements, depending upon which type of report we're talking about. So I'm just going to roll down the risk management report now. When we use that data structure, what's going to be the risk work item is what we're going to call either an ASIL or a risk record. And connected as parents to that risk record are going to be harms and the mechanism by which the risk is exposed to the users, or the hazard is exposed to users. So that mechanism carries an occurrence rate, the harm carries the severity, and we're going to do this kind of like a risk management table. And the mitigation work item is going to be design risk. And what we're going to do is we're going to more fully develop those design risks in the other types of FMEA. And of course, we have causes that are related to that as well. So these dotted lines represent relationships that aren't managed by the report. The solid black lines represent relationships that are. So when I create a new cause or a mechanism or a harm inside of the reporting structure, it's going to manage these relationships automatically. So I'm just going to quickly go through the other types. We have our design system FMEA that, again, we're going to have a design risk that's identified as a system design risk. The parents of that are going to be the system requirement and the design system function. That's what we're analyzing with the risk to understand what the mitigation strategy needs to be. And then we're going to have the mitigation to that design risk be design requirements. And of course, we're going to identify what those causes are as well. When we do this, of course, those design requirements are going to be broken down by discipline so that we understand whether it's mechanical, software, or usability, whatever the type of requirement that is. And then finally, we got our design failure mode analysis, which is going to be, again, we have this design risk work item, but the parents of this are going to be the design requirements that were identified in the last one. And this kind of goes along the data model I was talking about in my presentation. And also we're going to have functions. Instead of functional chains, we're going to have individual functions as they're deployed in one component of the system. So we'll analyze that requirement, which is really an outflow of the function, and the function to get the risk. And then we're going to have a set of physical requirements or attributes of the design that are necessary to provide that function that the design risk is analyzing. Okay, so that's kind of the progression here of the different types of work items you're going to see in the report. And so I just wanted to talk about that a little bit before we jump into the reports so we understand what's pivoting, and I'll talk about those as we go along. Okay, so let's jump over into the report. Okay, so we're in the report now, and it's a little bit of an eye chart. I hate to do this to you, but essentially we have a bunch of different fields we're analyzing. So left to right, we have that risk. We have a harm and hazardous situation, which is the mechanism. We're going to have analysis column, which is going to talk about each one of those, both pre and post mitigation, the occurrence rates, and then come up with what we're going to call a risk priority level, or what is the priority of this particular combination to the user. And then finally, we're going to have mitigation strategy, which goes down into those different reports, just like I talked about. So this is sort of the left to right. I'll blow this up and we'll talk about each one of these elements. So this item ID represents the risk item that we're evaluating, and this is the work item and what it is, the description of it. That hazardous situation is the mechanism, and that mechanism is going to have with it a rate of occurrence, which is we're going to call a P1 factor. So that's later in the report to the right. Then, of course, we have the harms, and the harm has a severity. Then we grab the P1, which is from the mechanism, the hazardous situation. Well, how often does that occur? How often does that mechanism occur? P2 is how often the mechanism translates into a harm. So maybe the mechanism is I'm energizing a case with main power, by which I would be exposing a user to the main power source or electromagnetic energy. How often that leads to shock as a harm, as opposed to how often it leads to electrocution as a harm. Those are two different P2s. The P2s are different for the different harms. So once we identify the harm along with the mechanism, we can identify how often that mechanism, if activated, would lead to the harm. That's what P2 is. And then we calculate a P, which is this pre-P1, P2, and that gives us the probability how often the harm occurs. And then we cross the occurrence of the harm with the occurrence or the severity of the harm, and that gives us what this RPL level is. Of course, once we do that, we can then evaluate what it would be after mitigation strategy, the entire mitigation strategy, and get an improvement in that RPL. That's really the whole point. Now, this mitigation strategy ends up being the risk control, and the risk control work item is one that is going to be processed further in the FMEAs down the road, but we can identify the risk type or the mitigation method, inherently safe by design, preventative measures, and labeling. Those are all different types of risk that we can evaluate, and we can identify them in this particular report as they progress down to the different FMEA types. Now, one of the really great things about this reporting structure is this is all live data. So this is a great way to display this data because it gives you all kinds of functionality. So for instance, if I zoom in here, and you can see, maybe I'll do a little more, you can see the work items moving underneath. Well, one of the really great things about this is it maintains that top level of description, even with different zooming, so we can sort of display this way we want to. Or if we wanted to minimize some of these columns, there's an ability to aggregate the columns and only show the pieces of it that you like, so that there's a more consolidated view of those different work items, really slick functionality. In addition to that, if I said, hey, I want to create a new one of these work items, and I say I want it to be associated, so in this case, maybe I want a new harm, I click on the harm, and that allows me to type in a new harm. And not only does it allow me to do that work in context, but it also maintains the linking relationships in the background. So I don't have to worry about, I have this new object that's built. Is it related to the risk work item? Is it related to the mitigations? Well, when you do it in context in the table like this, it does it all for you. It keeps all the linking relationships in the background so you can continue to work in a user interface rather than trying to walk back and forth between work items. And, if we also wanted to make some changes to, say, the P1 factor, we can put in the strategy that we want from our SOPs as to how we calculate what that P2 value is. Is it a 6 level? Is it a 2 level, 3 level, 5 level? Whatever we want, we can put into it. And so this selection process would reflect what it is that we have in our SOPs. Once we make that selection, it recalculates that post RPL based on what we expected the P2 factor to be. And of course, these mitigation risk controls are also something we can discuss in the meeting, make the changes in the table, and really get a slick view of it. So that was the risk management report, which is that top level where we're analyzing the impact to users. But in addition to that, we can also do the systems. So in this case, we have the design risk identified. That is the design risk that we're using as the mitigation, the next level up. And here we have a system requirement that we're going to analyze along with the function. And we're going to have a set of failure modes, failure effects, severities, rates of occurrence, and we can do another calculation and have a design risk that's associated with this particular item. So again, it's this level by level downshift. So the risk management report is the high level, And then the first line of mitigation is system, but we're also going to have design risks that are identified as well. So let's go back to our presentation and talk about that for a minute. Okay, I'm going to jump back now into the data model for the design failure mode analysis. So now we're looking at the requirement breakdown between the design requirement and the physical requirement. So as we do that, now we're going to have, from the systems modeling, we're going to have the design function that's deployed in one component of the system. And the reason that's important is because once we've identified one component of the system, we understand where it's deployed in the design. Is it deployed in a piece of software, in a piece of hardware, in the electrical design? All of that is needed to understand what discipline we're going to push the FMEA through. So just to be clear, this FMEA analysis is different for mechanical or software or usability. They have different constructions. So this is just a generic sense of it. But what we need to do is understand, okay, is this design requirement and the function that it's delivering, is that design requirement related to software where we have 100% assurance that something will happen, or a 0% because it's software? Or is it more related to usability? And we have to understand what the user is doing in the system and the outflows, cognition and perception errors. It's a very different construction. So we need to identify at this point what kind of a requirement it is. And the way we do that is by where the function is deployed in the system. So again, I'm going to jump out and talk in the tool and show you from a application standpoint how this is realized in the application and the work. Okay, so now that we're at the design level, the construction is similar to what we showed before, except in this case, we're identifying one function and one design requirement that we're going to be analyzing. And that design requirement is a characterization of the outflow of the function. So each one of these we're going to want to analyze. And what we're going to be doing is identifying the discipline associated with that requirement, because these different FMEAs have different construction. So if we have 3 or 4 of these FMEA types, that's one of the great things about this setup is I can just easily create another FMEA type. I'll just give you an example, like usability. We could have our perception and cognition error that leads to use error as an example. And we could have a different FMEA structure, different variables that we're analyzing. It's really very easy for us to build that into the construction. And then we have a failure effect, cause of failure. And again, we're going to rank it. We have the severity driven from the RPL at the higher level. And then we have the rate of occurrence. Now, this is a different scale than we showed before. So this is the scale for this particular report that we chose. And it's a 9-level scale going from, I think, 1 in a billion down to 1 of 1. So each one of these then is an order of magnitude more higher level of or lower level of occurrence as you go down the list. And that gives us the ability to select for almost any product type what that level of occurrence is going to be. We recalculate the RPN and then have a set of mitigations. Now, we can do this same construction for the process failure mode analysis. And you can imagine we take the physical requirements or the attributes in the design that we've identified as critical to the design performance. We take those and we run them through what part realizes that attribute. We would then identify the process that creates the part, process steps. We'd analyze each process step and we end up with a set of production controls, right? So it's really the same thing. And what this does is it sets up the process failure mode analysis with a characterization of the importance of each physical attribute so that we understand what the implication is. If that attribute isn't met, what's the implication to users as it goes up through this progression? So the real thing I wanted to express here, though, is this is a very easy format for us to just go ahead and create these analysis points as we go through this process. And that way we can analyze our product risk in the context of a user interface so that it's not confusing to people, the underlying data model. And it takes those work items, it drops it into the appropriate documents so that we can keep track of everything, not only in the context of this report, but also in approvable documents for the different work item types. So it's very important that this interfaces well with the rest of the work that we're doing. Okay, so we'll go back to the presentation now and finish up. I hope this gives you some teeth as to how this would be built out inside the application. Okay, one of the things I wanted to just mention briefly, this is the cybersecurity ISO document, the 15408. Talks about how we would do this kind of a risk assessment for cybersecurity. And I think this is kind of interesting because this is the kind of problem that you run into when we start talking about different kinds of FMEAs for different disciplines. Cybersecurity has its own vernacular and its own decomposition. And just to talk through this a little bit, we have an owner, we have countermeasures and vulnerabilities. Those countermeasures, how do they possess vulnerabilities? What's the relationship between vulnerabilities and countermeasures? What's the relationship between those vulnerabilities and how they lead to risks? And then we have threat agents and attack vectors. So this is a little bit of a different vernacular, although it's really kind of the same. So as we talk about this, we have this mechanism, right, that has an occurrence rate. We have the risk, which is identified as our ASIL or risk record. The threats are really injury or harm to users. So you can kind of start to see these parallels between the different FMEA types. So if we just use the same terminology, we can use the same work item types. Again, the vulnerabilities are really the errors or the root causes, and the design mitigations are our design requirements that are needed to assure that those vulnerabilities are controlled. So this is one of the things I think it's really interesting. What we want to be able to do is have one data model for the design and different analysis techniques that use the terminology that each one of these disciplines expect, so that when the cybersecurity people are operating inside their FMEA, they're in a familiar environment that is designed in a way that makes sense to them, and the terminology makes sense to them, but the data model builds into the requirement set in the same way, so that as we report on it, what is the risk associated with anything in the design, terminology can be normalized so that when we run a report, it all looks the same. So this is just an example, I think, a good one of a cybersecurity problem and how we should handle that as part of the data model. Okay, so now the final one is process failure mode analysis. And what we're going to evaluate here are these physical requirements, which are attributes of the design. They're not function, they're attributes of the design that are necessary to deliver the design function. So we're going to take those process requirements or physical requirements, and we're going to break them down. And the way that's done is the physical requirement is contained inside a part. The part has characteristics, so dimensions, materials, different manufacturing processes, and those different characteristics in the parts are delivered by a process. The process is delivered by process steps. And then we're going to evaluate each one of those process steps for the risk of it not delivering the characteristic that we've identified in the physical requirement. Of course, that leads to root causes. And then we're going to end up with process controls on top of that. So what we really want to do here is evaluate the overall process to make sure the controls are in place to deliver that physical requirement. And again, each one of these are stamped with high risk if they are high risk. So we understand the rigor with which we're going to have to, what's the CPK level for this particular attribute to be sure that we deliver to the design what's necessary. So you can kind of see how we're progressing all the way down the decomposition of the design in order to prevent us from the decomposition of the design in order to deliver what's necessary in the manufacturing process up to the design. A lot of times what happens is there is no connection between what's required in the device function to how we're going to deliver the process. And the problem with that is I've seen a lot of examples of people sitting around doing process failure mode analysis, talking about what could go wrong if this process isn't delivered. It really ought to be delivered as part of the decomposition of the design. So it's very clear if this particular process control fails, what the implication is to the overall design, the system level, the design level, and then of course what's delivered to the users. Okay, so this is kind of a little bit of a summary. We have this risk record at the high level that pairs the mechanism with the harm. Then what we do is we have the system requirement that's evaluated by the system FMEA, the design requirement evaluated by the design FMEA, physical by the process, and then process controls to give us a complete set of controls to assure that that problem that we've identified in the risk record doesn't occur. So if we want to talk about a complete picture from a design decomposition standpoint, this is the requirement set. We have then built into the requirement set these FMEAs to evaluate and assure that we have everything in the requirements that's necessary to control the risks we've identified. We have the systems modeling on top of it saying what are the capabilities and functions that need to be delivered by the requirements. We have test cases that are associated with each of the requirements to show the evidence that we comply with our definition of good product. We have external standard clauses. We'll talk about those more next week, but essentially, what are these external standards and what requirements do they place on the design? And then we have parts or outputs of the design that are needed to show what is going to be the device under test that we utilize in the test case to provide that evidence. So we need to understand how this is related to the physical design as well. So that's the complete picture. So hopefully between the demonstration and this sort of technical discussion of how the data is interrelated with one another, this gives you a better sense of how it is that we can develop a system like this in a structured tool so that we can systematically walk through the design and understand what the implication of any particular requirement is, whether we have a complete set and a sort of a closed list that we can check off one at a time to get to the end of the design in a way that's systematic. So really appreciate your time. Again, this is all my contact information. Feel free to give me a ring, link in, and schedule a meeting. So I look forward to talking to you next week and appreciate your time.